They began with high-resolution satellite imagery, ground-penetrating radar, and thousands of wind measurements to map the shifting dunes and identify areas stable enough for construction. Dry, cracked, and almost impossible to cultivate. Summer temperatures soared above 110 degrees Fahrenheit. Rain fell only for a few weeks each year, and underground aquifers slowly dried up with every generation. Amid the harsh deserts of the Middle East, where there's nothing but rocks, wind, and burning sun, the people of Israel achieved something that stunned the world. The entire canal alignment had to avoid the wind corridors, where a single sandstorm could bury the whole worksite overnight. Hundreds of bulldozers were deployed to flatten the dunes, cutting down the high ridges and redistributing the sand into lower areas. After the bulldozers had leveled the dunes, the sand still needed to be stabilized. Engineers discovered that injecting water into the loose surface helped bind the grains together, creating a denser and more cohesive layer. Using long sprinkler arms and underground pipes, they sprayed controlled amounts of groundwater across the site, allowing moisture to penetrate several inches deep. A long green ribbon winds across the golden desert, the green artery of Israel, the artificial lifeline connecting the north and south of the country. The transformation went beyond the fields. Villages were rebuilt, children had schools, and high-tech farms rose from the sand. The longitudinal slope was held within 1 inch per 100 feet, an incredibly tight margin over such distance. Survey crews rechecked elevation with laser leveling instruments every 160 feet to ensure the canal floor stayed perfectly aligned. Most of the excavated sand was reused to build up both sides of the embankments, forming levees 10 to 16 feet high. They turned all that seawater into fresh, drinkable water using cutting-edge technology inside massive desalination plants. That's why the lining phase became one of the most critical stages of the entire project. First, the canal bed and slopes were moistened and leveled with a 2-inch layer of fine sand. Then concrete panels about 4 to 5 inches thick were poured into sections measuring 16 feet long by 10 feet wide, each separated by expansion joints. These joints were filled with hot bitumen sealant to prevent seepage and allow thermal movement. In areas with unstable subsoil, an additional HDPE geomembrane layer was placed beneath the concrete, fixed with steel anchors and covered with a protective sand cushion. They carved more than 12,000 kilometers of canals through the desert to create a massive artificial river, channeling billions of liters of water from the Mediterranean Sea to sustain an arid nation. Under immense pressure, seawater is forced through semi-permeable membranes, each pore hundreds of times smaller than a strand of hair. This invisible wall allows only pure H2O molecules to pass through, while salts, heavy metals, and trace chemicals are left behind. That contrast sparked Israel's boldest gamble to pull the sea inland, deep into the heart of the desert. The Desert Water Project was officially approved in 2000 with an investment of nearly $3 billion. Land that once cracked under the burning sun started to come back to life. Farmers who had once left because of drought returned, pitching tents, driving stakes, and plowing the first fields of their lives amid the sand and rock. Water from the main channel of the national water carrier was divided through a network of secondary canals, pressure pipes, and drip irrigation systems that delivered it directly to each plant. A solid foundation built from nothing but sand and water. Once the groundwork was complete, hundreds of excavators and massive dump trucks began one of the largest digging operations ever undertaken in modern Israel. Every day, around 70,000 tons of sand and soil were removed from the Negev desert along a construction corridor stretching nearly 250 miles. Over 1,200 engineers, operators, and laborers worked in rotating shifts, enduring daytime temperatures that often exceeded 115 degrees Fahrenheit.